How do you convert from grams to the number of particles? Let's do a sample problem. How many particles are in 9.51 grams of oxygen gas, O2? The first step, as always, is going to be to calculate the molar mass of O2. O2 has 2 atoms of oxygen, and so the molar mass is simply going to be 2 times the molar mass of oxygen, which is 2 times 15.999, which just equals 31.998 grams per mole of O2. The next step is to take our input, 9.51 grams, to create our little picket fence. And we're going to go from grams of O2 to moles of O2. And then knowing that there are 6.022 times 10 to the 23rd molecules in 1 mole of O2, we can determine the total number of molecules in 9.51 grams of O2. And let's do that. So grams of O2 is in the numerator here. So grams of O2 has to be in the denominator in our next step. And we're going to moles of O2. We know that there are 31.998 grams of O2 in every 1 mole. Grams of O2 cancels out. Next, we have moles of O2 in the numerator. We need to cancel out moles of O2. And we're going to number of particles. And we know that in every mole, there are 6.022 times 10 to the 23rd molecules of O2. And so here, moles of O2 cancels out. Notice I didn't put any units here. You can put molecules if you want. Molecules of O2. And so now, in this multi-step problem, we have 9.51 times 1 times 6.022 times 10 to the 23rd divided by, in parentheses, 31.998 times 1. And the final answer is going to be in units of molecules. Let's do this calculation. And so we have 9.51 times 6.022 times 10 to the 23rd divided by, in parentheses, 31.998. And we get 1.78977 times 10 to the 23rd. To correct significant figures, we have 3 sig figs in our input. So we get 1.79. This equals 1.79 times 10 to the 23rd O2 molecules in 9.51 grams. Does this make sense? Well, we know that 1 mole of O2 has a mass of 31.998, and 1 mole contains 6.022 times 10 to the 23rd particles. 9.51 grams is much less than 31.998. And so we predict that we should get less than 6.022 times 10 to the 23rd particles. And indeed we do. We get 1.79 times 10 to the 23rd. What about going in the opposite direction? What if we want to go from number of particles to grams? Let's do a practice problem. What is the mass of 2.38 times 10 to the 23rd formula units of NaCl? As always, our first step is going to be to calculate the molar mass of NaCl. The molar mass on the periodic table for sodium is 22.990. There's only 1. And for chlorine, it's 35.454. And so 22.990 plus 34 plus 35.454 is 22.990 plus 35.454 is 58.444 grams per mole. In other words, 6.022 times 10 to the 23rd units of NaCl has a mass of 58.444 grams. And we know that in 58.444 grams, we will have 6.022 times 10 to the 23rd formula units, because that is 1 mole. Well, we have 2.38 times 10 to the 23rd. This is less than 6.022 times 10 to the 23rd. And so we're going to predict that we should get less than 58.444 grams for our final answer. Let's do the math. So we have our input, which is 2.38 times 10 to the 23rd formula units of NaCl, which I'm just going to say 2.38 times 10 to the 23rd NaCl. Draw our picket fence. And we need to go from units to moles. We know that we have 6.022 times 10 to the 23rd NaCl in 1 mole of NaCl. Here, the NaCl cancels out. And then we're going to go from moles to grams. Well, we know that in every 1 mole of NaCl, we have up here 58.444 grams. Our moles of NaCl cancel out. And so now doing the math, we get 2.38 times 10 to the 23rd times 1 times 58.444 divided by, in parentheses, 6.022 times 10 to the 23rd. Now let's just plug this into the calculator. So we have 2.38 times 10 to the 23rd times 58.444 divided by, in parentheses, 6.022 times 10 to the 23rd. And we get 23.098093666. We have 3 significant figures in our input, so our answer is going to have 3 significant figures. And so we get roughly 23.1 grams of NaCl in 2.38 times 10 to the 23rd units. Does this match our prediction? Well, 2.38 times 10 to the 23rd is less than 6.022 times 10 to the 23rd. And so we predict that we're going to get less than 58.444 grams because that's the mass of 1 mole. And indeed we do. We get 23.1 grams. So our answer matches our predictions. Lastly, how can we go from grams to number of atoms? This is a bit of a tricky question, because some might be led to believe that we can go from grams to number of particles and then we're done with the calculation. But notice it doesn't say number of molecules or number of units, it says number of atoms. When given a compound consists of more than 1 atom. Let's do a practice problem. How many atoms are in 22.0 grams of glucose, C6H12O6? As always, the first step is to calculate the molar mass. Glucose has 6 carbons, 12 hydrogens, and 6 oxygens. And so the molar mass of carbon is 12.011. So we have 6 times 12.011. Molar mass of hydrogen is 1.008. So we have 12 times 1.008 plus 6 times the molar mass of oxygen, which is 15.999. Now plugging this into the calculator, we get 6 times 12.011 plus 12 times 1.008 plus 6 times 15.999 equals 180.156. Grams per mole. So 1 mole of glucose has a mass of 180.156 grams. In other words, 6.022 times 10 to the 23rd molecules of glucose has a mass of 180.156 grams. How many atoms are in glucose? Well, we look at the formula. We have 6 carbons plus 12 hydrogens plus 6 oxygens. That's 6 plus 12 plus 6 gives a total of 24 atoms. Doesn't matter what the atoms are. That's just 24 total atoms in 1 molecule of glucose. And so now let's take our inputs and go from 22.0 grams to total number of atoms. So we have 22.0 grams of glucose. We draw our picket fence. And we know that we're going to have grams of glucose at the bottom and moles at the top because we're always going from grams to moles. We have 180.156 grams in 1 mole. Going from moles, we're going to go to number of molecules. We know that in every 1 mole, moles at the top, so moles has to be in the denominator here. So it cancels out. We have 6.022 times 10 to the 23rd molecules. You can also abbreviate molecules MLC. Those cancel out. But in every molecule, in every 1 molecule of glucose, as we calculated here, we have a total of 24 atoms. MLC cancels out. So now we have 22.0 times 6.022 times 10 to the 23rd times 24 divided by, in parentheses, 180.156 times 1 times 1. And this should give us the total number of atoms. And so we get 22.0 times 6.022 times 10 to the 23rd times 24 divided by 180.156. And we get 1.7649 times 10 to the 24th. We're rounding down since we have 3 significant figures in our input. We have 3 in our output. 1.76 times 10 to the 24th atoms. We didn't make any predictions. We can see here that 22 grams is much less than 180.156. So we know we have much less than 1 mole. How many atoms are in 1 mole of glucose? Well, 1 mole of glucose is 6.022 times 10 to the 23rd particles, 23rd molecules. And then we have 24 total atoms in 1 mole. And so For the total number of atoms in 1 mole, we get 24 times 6.022 times 10 to the 23rd, which gives us 24 times 6.022 times 10 to the 23rd. Gives us 1.445 times 10 to the 25th atoms. 1.445 times 10 to the 25th atoms in 1 mole of glucose. We have much less than a mole. Looking here, 22 grams is way less than 180. And so this number of 1.76 times 10 to the 24th isn't very surprising. And this does match with what we